In today's video, we are going to discuss about laws of motion. Before we start, just make sure that you have subscribed to the channel and enabled the notification icon. Starting with the three types of inertia. Inertia of rest, the property of a body due to which it cannot change its state of rest by itself. Inertia of direction, the property due to which a body cannot change its direction of motion by itself. Inertia of motion, the tendency of a body to remain in a state of uniform motion in a straight line. Newton's first law of motion. A body continues its state of rest or motion unless an external force is acted on it. If external force is equal to 0, then acceleration is also equal to 0. Newton's second law. The rate of change of linear momentum of a body is directly proportional to the external force applied on the body in the direction of force. Force is equal to rate of change of momentum, which is equal to mass into acceleration. SI unit of force is Newton. If mass is a constant, force is equal to m dv by dt equal to ma. Dimensional formula mlt raised to minus 2. Conservation of linear momentum. If there is no external force acting on it, total momentum of an isolated system of interacting particles is conserved. If velocity is a constant, force is equal to v dm by dt. Convey or belt and rocket propulsion. If external force is equal to 0, then rate of change of momentum is also equal to 0. That is, initial momentum equal to final momentum. Impulse. Impulse is average force multiplied by change in time, which is also equal to change in momentum. That is, impulse equal to change in momentum is equal to integral f dot dt area under force and time curve. Newton's third law. To every action there is always an equal and opposite reaction. Action and reaction act on different bodies and not on the same body. Action and reaction forces are of same type. We cannot produce a single isolated force in nature. Forces are always produced in action-reaction pair. Due to no time gap, any one force can be action and other reaction. Applicable for all the interactive forces, example gravitational, electrostatic, electromagnetic, tension, friction, viscous force, etc. Forces. Normal contact force always acts along the common normal of two surfaces in contact, always directed towards the system. It is an electromagnetic type of force. Normal force on a block is N, and normal force is given by mg, mass into acceleration due to gravity. Tension force acts along the string and away from the system on which it acts. Tension in a massless string remains constant throughout the string if no tangential force acts along the string. This is force applied by a string on an object or force applied by one part of a string on the remaining part of the string. It is an electromagnetic type of force. Friction force. Rolling friction. The force of friction which comes into play when one body rolls or tends to roll on the surface of another body. Sliding friction. Resistance offered to the relative motion between the surface of two bodies in contact. The frictional force F is directly proportional to the normal force N exerted by the surface of the body. F is directly proportional to N, or force by N is a constant called mu. The friction force depends upon the nature of surface in contact and independent of the area of contact. Types of friction. Static friction acts when a body is at rest on application of a force. Static friction is equal to mu s into n. Limiting friction acts when a body is just at the verge of movement. Limiting friction equal to mu s into n. Kinetic friction acts when a body is actually sliding. Kinetic friction equal to mu k into n. Circular motion. Kinematics of uniform circular motion. A particle moves in a circle at a constant speed. Angular displacement theta SI unit rad or degree. Angular velocity omega. Omega equal to delta theta divided by delta t. Unit is radian per second. And instantaneous angular velocity equal to d theta by dt. Centripetal force. Centripetal force is equal to ma. mv square by r, which is equal to mr omega square. Velocity is equal to omega cross r. V is linear velocity tangential vector. Omega is axial vector and r is radius vector. Kinematics of non-uniform circular motion. Speed of the particle in a horizontal circular motion changes with respect to time. Tangential acceleration. Acceleration is equal to alpha cross r. Centripetal acceleration F is equal to mass into centripetal acceleration, which is equal to mv square by r equal to mr omega square. Tangential force equal to m into tangential acceleration. Net force equal to mass into root of centripetal acceleration square plus tangential acceleration square. Centripetal acceleration is responsible for the change in direction of movement of particle. Horizontal circular motion, conical pendulum. T sin theta is equal to mv square by r and time cos theta equal to mg. Velocity equal to root of rg tan theta. Angular speed omega equal to velocity by r, which is equal to root of g tan theta by r. Time period is equal to 2 pi by omega, 2 pi root of r into g tan theta, which is equal to 2 pi root of L cos theta divided by g. Vertical circular motion. Particle oscillates in lower half circle. Condition of oscillation is velocity should be greater than 0 and less than or equal to root 2 gr. Particles moves to upper half circle but not able to complete the loop. Condition of leaving the circle. Velocity should be greater than root 2 gr and less than root 5 gr. Particles completes loop. Condition for looping the loop. Velocity should be greater than or equal to root 5 gr. Motion of a car on a level road. Velocity maximum equal to root mu rg. Motion of a car on banked road. Optimum speed of a vehicle on a banked road. Velocity is equal to root rg tan theta. Maximum safe speed on a banked frictional road. Vmax equal to root of rg into mu plus tan theta divided by 1 minus mu tan theta. Minimum safe speed on a banked frictional road. V minimum equal to root of rg into tan theta minus mu divided by 1 plus mu tan theta. Solving problems in mechanics. Draw free body diagram of bodies in the system. Choose convenient part of the assembly as one system. Identify the unknown forces and accelerations. Resolve forces into their components. Apply summation of force equal to mass and acceleration in the direction of motion. Apply summation of force equal to 0 in the direction of equilibrium. Write the constraints relation if exist. Solve the equation summation of equal to ma and summation of f is equal to 0.